Hi, my name is Sam Shapiro. I'm a fourth-year computer science major at Georgia Tech, and this is my CS3651 prototyping devices final project. For my zombie apocalypse survival device, I decided to use a light sensor connected to a DC motor to trigger the falling of a golf ball onto a metal pot, which causes a really loud sound, which pops the zombie. The entire device is made up of 3 separate circuits, 2 of which are built on breadboards and connected to the Arduino, which is powered through a wall outlet. The third circuit is soldered to a protoboard and powered by batteries. The first circuit is used to convert AC wall power into a 5-volt DC output that can power the Arduino. This is done using a full wave rectifier and a linear regulator, similar to what was done in Skill Demo 10. I used a 100 microfarad capacitor to smooth the signal going into the linear regulator, and used a 5-volt linear regulator to ensure that no more than 5 volts are being transferred into the Arduino. The voltage out of the linear regulator is connected to the V-in pin on the Arduino board. The ground from the linear regulator is also connected to one of the ground pins on the Arduino. The next circuit is the light sensor. I used a photo-resistor, which is attached to both power and ground, which is also in series with another resistor. This was used to ensure that the values that were being taken in by the photoresistor were distinct enough to be able to tell slight differences in the shadow that appears on the resistor. I attached a wire flowing through the photoresistor circuit into an analog pin on the Arduino and used that to read in the amount of light coming into the resistor at any given time. I used this value of the amount of light in the resistor to determine whether or not I should send a low or a high digital signal into the base of a transistor that was also on the same breadboard. The collector of the transistor was connected to the other ground on the Arduino board, and the emitter of the transistor was connected to the negative end of the DC motor. The positive end of the DC motor connected back into the breadboard and was connected to the 5-volt power out of the Arduino. The Arduino is programmed such that when there is a low enough light value going into the photoresistor, a high voltage is sent into the base of the transistor, causing the circuit to be complete through the DC motor, causing it to spin. When the light goes back high into the photoresistor, the signal is sent to low and the motor stops spinning. To keep the amount of light flowing into the photoresistor somewhat consistent until somebody walks in front of it, I've used an LED which is powered by batteries. This is soldered onto a proto board and uses a couple of resistors to weaken the light so that it does not blow out the LED. The mechanism which causes the sound uses a string which is tied to the wheel on the motor. This string is tied across the room to a roll of tape. This tape is right in front of a golf ball, and when the string is pulled tight, the tape moves and the golf ball is pushed off of the desk and onto the pot. And the opening on the bottom of the pot causes a large sound to be released when the golf ball hits the pot. This radiates throughout the room and is loud enough to surprise anybody who happens to witness it. Here is the entire mechanism in action. The skills used in this project include soldering, using batteries to power a circuit, using an AC wall adapter to power a circuit, using a full wave rectifier and linear regulator to convert AC to DC power through a wall outlet, using a photocell to read in light values, powering a DC motor using a transistor, and writing Arduino code which is based off of sensor input. This project was very challenging to complete at home. The only electronic materials that I have are those that came in my toolbox, and I had no other sensors available to me except for one photoresistor. So that was the only thing that I could use to take in any outside sensor data. Another challenge that I had was finding materials to create some sort of mechanical action. I knew that I had the wheel, but I had to borrow string in order to make the wheel as functional as it was. Another challenge that I had was making sure that all 5 volts going into the Arduino were not sucked out of the Arduino when powering the motor. Initially, whenever the sensor was set off by low light, the motor would stutter rapidly. However, this was not the case when the Arduino was plugged into my computer, only when it was plugged into the wall. To fix this, I added an extra resistor going into the transistor, and I switched the DC motor from taking in power from the transistor to taking in ground from the transistor. This fixed my problem, as now whenever I applied low light to the transistor, the wheel would spin without any stuttering. This project was both fun and challenging, and I had a great time over the semester working on all of the skill demos along with this project. The hands-on experience has been really, really useful, and I've enjoyed getting to work with stuff that I haven't really been able to touch in the rest of my CS curriculum. Thanks for watching, and thanks for a great semester.